Alright you guys, welcome to a quick little video on simplifying radicals. Trying to do the autofocus right now, but we'll see. Alright, so hopefully that doesn't try to autofocus during our video. Alright, there's really only four big things that I want to cover with y'all, and the first one is basic multiplication. Now, it sounds basic, but it's not, right? You have to be able to know that you can't multiply this 5 into the radical. In fact, what you actually have to do is multiply only the things that are inside houses together, and then the things that are outside, you can multiply those together. Now, there's technically a 1 out here, right? So, whenever you actually multiply this, you say, well, 1 times 5 is just 5, and then the square root of 48 times the square root of 20 is, if I've done my math right, 960. Now, from there, we're actually going to do something called prime factorization. So, really, it's just a fancy way of saying that I'm going to break up this number into smaller factors until I can't break it up anymore, and the numbers that I have left are prime, hence prime factorization. Now, I'm going to do this using a factor tree, which is kind of a nice visual representation of those factors. And one of the things that, the reason why I'm doing this is because I want to get that radical to look nicer than just 960. I want to break it up. I want to simplify it. So this guy is going to keep going. I have 2 and 48, 6 and 8, 2 and 3, 2 and 4, and that can keep going. Now, if this is a factor tree, I like to think of all of my little prime factors as leaves on this tree. So if they're not serving as a branch, I like to go ahead and circle them so as not to confuse myself later. Now, what we're going to do is we're going to start taking pairs out of this tree, but I want you to notice this 5. If it's outside of the radical, you just leave it there. Nothing happens to it, so I'm just going to make sure that I carry it over. And I'm going to start finding pairs. Now, y'all know that I like to akin this to marriage. So, you find a pair, they leave the house, and they multiply. They become 1 and they multiply. Now, why do I say that? Well, these two pairs, if you had actually left them inside of the square root, 2 times 2 is 4, so square root of 4 is just 2. So whenever you find a pair, it comes out of the square root and it is represented only once. And then it is multiplied to whatever is outside. So let's go ahead and find some more pairs. I have another pair of 2's, they come out, they become 1, they multiply. I have another pair of 2's, they come out of the house, they become 1, they multiply. And finally, left still in the little house, all alone without a pair, are 3 and 5. Well, from here, what you can do is you just multiply all the outsides. So that's what, 10 times 4, so that's just 40. And you can multiply the insides. And that is your final answer. Now notice how this number is a lot nicer than that 960 that I had before. So that's multiplication. Let's actually look at division. Now, division works a lot the same way, in that with multiplication you couldn't multiply the things outside with the things inside, so you just want to make sure that you leave the outsides together and the insides together. Now this is technically, if you want to be really precise about what you got, a 1 divided by a -1, well, that's just a -1, so I'm going to stick a negative sign out in front so it doesn't bother me anymore and I don't have to think about it. Now I'm left with this root 7 over root 28. Well, that's really just a 7 over 28, because remember, you can multiply and divide the things inside of the house. So if you're very careful, you realize that this is just 1/4, and you can break it back up again to get much nicer fraction. Square root of 1 is just 1, and square root of 4 is just 2. Much nicer than what you started with, right? Okay, well, what happens if life is not that good? What happens if I can't actually divide the stuff inside? So let's say that I get something like this, right? There's no way that I can divide 5 by 7. Both of those are prime numbers. And so I get negative, oh, well, the same thing, right? So when you feel like there's nothing that you can do, and when you try to rewrite, you get the same thing, you want to look at the denominator. And really what we want to try to do is just at least express this number so that there's no radical in the denominator. We do not like things expressed this way. We want to express it in a nicer way. So what we're going to do is actually rationalize the denominator, which is just a fancy way of saying that I'm going to multiply by a fancier way of saying 1. Because you can always multiply by 1, right? And root 7 divided by root 7 is just 1. And again, I'm just being a sneaky mathematician where I'm multiplying by a sneaky version of 1 in order to get this to look nicer. Now, if you look at the denominator, this is root 7 times root 7. Well, that's just root 49. Well, that's just 7. This will always happen with any number, right? If you're multiplying two roots that are the same, that number will always just come out. So this is 7, and believe it or not, this is your final answer. Please don't try to simplify. I've had some people that want to say, well, hey, I know that 35 divided by 7 is just 5, so they try to say that this is the answer. No, you cannot do that. Why? Again, only the things that are outside of a house can be divided. Please don't try to divide into the house. Final answer. Alright, that was a word on division. And probably some of your most difficult problems, believe it or not, are just addition and subtraction problems, which are about combining. So, look at this guy. And one of the things is, you want to make sure that you really only combine like houses, right? So let's say that I had this, well, that would be square root of 5. Why? You might as well be having 3x minus 2x, well, you know that that's just x. So these little radicals behave a lot like just a common term, right? They just behave like a variable, x. So you would think, well, I'm done here. I mean, I might as well have 3x minus 4y minus 5z. None of the houses are the same. I can't combine them. Well, this kind of problem is trying to just trick you. It's trying to cause some trouble. So what you're actually going to do is you're going to break down each of these houses into their factor trees. So let's do that. I'm going to have 8 and 10, 2 and 5. These guys keep going. 4 and 5, 2, 2, 5, 9. Right? I'm going to go through, and so as to not confuse ourselves, I'm going to do every tree in a different color. So that was 80. This is 20. And this guy was 45. So let's rewrite with our simplified radicals. So remember, whatever's outside, you just keep outside, right? Nothing really happens to that guy. I have a pair of 2's. They come out of the radical. It's represented only once, and you multiply. I have another pair of 2's. Comes out of the radical, represented once only, and it multiplies. And then, forever alone, poor little 5 is stuck in there, right? Then you do the same thing for these pairs, and recognize that what's actually going to come down here is a negative 4, so make sure you keep that sign, times 2, again, alone is that 5. This guy comes down, nothing happens to him, and I have 3, and again, poor little 5 is alone. So when you do your multiplications on the outside, let's see, 3 times 4 is 12. You recognize that this is just combining like terms. I mean, it's like if you had 12x minus 8x minus 15x. It's just like that. You're just combining like terms. So you're going to say that this is, if I've done my math right, negative 11 root 5. Now notice that I really did just combine. Please don't try to multiply the roots and say that this is 125, just like you would not say that this is negative 11 x cubed. No, you're just combining. Please don't do that. This is your final answer. I think that you could probably take these 4 problems and tackle any other more difficult, any other problem that's a little bit more difficult. So good luck, you guys. Good luck on your test.